We're still dealing with graphs of linear. Okay, this time we're going to talk about parallel and perpendicular lines when we look at two linear equations so that we can determine if they are parallel or if they're perpendicular. Now in these graphs, since the graphs are the same and the graphs intersect at exactly one point, and the graphs are parallel if they do not intersect. So we have the red line. The red line has stayed the same throughout. On the second part, on the second slide, our graph right here, where this intersects, this is where they cross in exactly one point, and we're going to see if they're perpendicular. And then these right here, they have the same slope, and these are parallel. They do not intersect. Alright, the graphs shown below of the linear equations y equals 2x plus 5 and y equals 2x minus negative 3. If you look at the slopes are identical, and the y-intercepts are 5 and negative 3. The lines do not intersect, and they are parallel. So let's think about if they have the same slope, then they are parallel. Parallel non-vertical lines have the same slope, but they have different intercepts. They can't equal the same thing. Parallel horizontal lines, y equals p and y equals q, where p does not equal q. Again, you can't have the same horizontal line. They can't go through the same thing. Parallel vertical lines, again, x equals p and x equals q. They can't be the same. So determine whether the graphs of the lines y equals 2x minus 3 and 8x plus 4y equals 6 if they are parallel. You can do it by graphing, or you can just set it up and solve for y. You remember, put it in y equals mx plus b. This one's already done for us. So let's do this one. If we subtract 8x from both sides, we get 4y equals negative 8x minus 6. Divide by 4. Y equals negative 2x minus 3 halves. So do they have the same slope? They do have the same slope. So if they have the same slope and the the y-intercepts are different, then these are parallel. So yes, they are parallel. Now, perpendicular lines on a plane are lines that intersect at exactly one point, and they measure 90 degrees. The slopes of the lines here are 2 and negative 1/2. Note that 2 minus 1/2, or 2 times a negative 1/2 equals a negative 1. So the product of the slopes is negative 1. We're going to talk about another way to tell. So two non-vertical lines are perpendicular if the products of their slope is negative 1. If one line has m and the slope of the other line perpendicular to it is negative 1 over m. If one equation in a pair of perpendicular lines is vertical, then the other is horizontal. The equations are in the form of x equals a and y equals b. The way I simply remember it is if they have opposite signs, and flipped. So let's look at this one. This is a positive 4x. So let's see if we say x, or if we subtract x from both sides. So now we get 4y equals negative x plus 4. Divide by 4 all the way through. So now we get y equals negative 1/4 x plus 1. Notice that if we write this as 4 over 1, and then the slope of this one is negative 1/4, they are opposite signs, one's positive, one's negative, and they are reciprocals or they are flipped of each other. You can also say 4 over 1 times negative 1 over 4. You get negative 4 over 4, which is simply negative 1. And because that is negative 1, these lines are perpendicular. So we are finished here.